Good afternoon, everybody. As our attendees are trickling in, let me start by saying please no recording. This presentation and the corresponding slides are copyrighted by Robson Forensic and may not be recorded, copied, distributed, or otherwise used without authorization. So for today, we have a presentation on hazard tree investigations from our forensic arborist, Christopher Larson. If you have any questions as the presentation progresses, you can submit them via the Q&A button at the bottom of your screen, or you can email them to us at inquiries@robsonforensic.com. We'll save some time at the end to address those. And I'll hand it over to Chris.
Well, thank you, Ann. I just wanted to say good afternoon to everybody, and we're going to be talking about trees and investigations of trees involved in litigation. And I'm going to give an overview of what I do as an arborist in trees that are involved in this litigation. I'm going to go over what type of inspection that I do and some of the visual cues that I'm looking for on these inspections that would indicate a greater likelihood of tree failure. And I'll get into what type of notice, the causation, how did the tree fail, and I'm going to talk about the top 5 tree case subtleties that I see in the tree cases that I deal with, and then we're going to have some time for some questions. My name is Christopher Larson, and I've been working with trees professionally in both the public and private sectors for 25 years. And I have a bachelor's of science degree in urban forestry from the University of Wisconsin-Stevens Point. And I'm a board certified master arborist and a qualified tree risk assessor through the International Society of Arboriculture. I'm just going to give you an overview of what type of cases I deal with as an arborist. The common case that I get is going to involve generally a tree has failed and it has caused a serious injury or a fatality or significant property damage. And sometimes that property damage might just be the tree itself. And that's where you get into like a tree appraisal or a tree valuation. And usually in those type of situations, it's more than one tree if I'm going to get involved. But typically I'm looking at the standards of care, and like I'm looking at this going, this is what I'm going to come across in a typical tree case. A tree has failed, property was damaged, someone was seriously injured or killed, and I have to look at it and see if it was preventable, see if there were standards of care that weren't followed. And we do both plaintiff and defense cases, so I have to look at it from the angle too, like, was this tree sound or was it a force of nature? And I'm going to refer to this excellent graphic that Robson put together with, it has all these different visual cues that I'm going to look at in an inspection. And there's descriptions pointing to some of these different visual cues. And I'll go through some of them, mainly the main ones that I use and look for in a lot of the inspections. And but we're gonna, before we do that, let's talk a little bit about what type of inspection that I do as an arborist. An inspection isn't just the tree itself, it truly is a site inspection. So I'll be looking at the site to see, okay, is this tree, is it down in a valley and it's not exposed to high winds, or is it way up on top of a hill and it's exposed to wind and all the elements of nature? I'm also looking at it in relation to different structures, different uses that people might have. Are people congregating in a certain area within the striking distance of this tree? Is it by a roadway? I use pretty basic tools for the most part when you're doing the site inspection and inspecting the tree. And one thing I do like, this is kind of these tools that you can kind of see in this picture. Those are the pretty basic tools, and I like using the compass on the cell phone because it will actually have your GPS coordinates too. And it can be more advanced. Like I'm measuring, I'll typically measure tree diameter, tree height, compass orientation I was mentioning is for like tree felling cases. If you need to know, did the tree fall the way it was supposed to fall? Was there decay in a certain side of the tree and it fell that way? And was that a likely cause, or was it significant enough that the decay weakened it? And what are the distances to structures? Is it 1 times the tree height? Are those tree defects significant? Is there more than one defect? And I'm looking at the soundness of the tree. Like in some cases where it truly could be like hurricane force winds, maybe the tree didn't have a lot of defects and was fairly sound. We do, like I mentioned, we do both plaintiff and defense cases. So we're looking at looking at this objectively and figuring out the how and why. And there can be cases where we use more advanced inspection equipment than this. You might have a tree failure where the defect is up high and the tree is unstable, but the tree's still there, and you might use a drone and get aerial, or you can use resistographs and sonic tomography to get a more detailed view of decay in some of these trees. I'm going back to this graphic that I mentioned earlier that points out a lot of these different visual cues that I look for on these inspections. And I'm circling a large piece of deadwood. This deadwood it's large and it's at height in the tree. And for it to be the higher up in the tree it is, the more velocity it's going to get when it gets to the ground or when it strikes an object, and it's going to bring more force and cause more damage. This large piece of deadwood up in this tree, if there are bike paths, if there's a driveway, if there's a structure or a place where people congregate nearby, this deadwood can get brittle, and it's just a great risk to anybody that's going to be in and around there. And the other thing that this large deadwood indicates, when it's all up at the top of the crown, that also is indicating a dying tree, and I'm really looking out for those type of defects. I'm circling in on this cavity at the base of this tree in this diagram, and a cavity with an opening, you're going to measure the extent of the opening, and then it's important to note that a cavity can be both in the trunk or it can be further up in the branches of the tree, and it doesn't always have an opening. Further up in the tree, it's going to have some sort of opening for that cavity to exist, but there's cases where a certain species of tree, they have what's called a taproot, which is a carrot-like root that comes off at the base, and it's important when the tree is young, but it starts to die back over time, and you can get a hollow in there without an opening or major crack. It's not quite as obvious. But the big point of cavities, they're indicators of advanced decay. And like, this is obviously one extreme. This tree has been long gone for a while, and it has a cavity with multiple openings. But you can look at other trees where there's the cavity and there's an opening on one side, and this cavity goes all the way up to a large branch that actually failed because of the dieback and the tissues that actually connect that branch. And there's rot in here, but what we're looking at in these cavities is what is the ratio of the decayed or hollowed out wood to the sound wood, and that gives us an idea of like how bad the stability was compromised. Like on this particular tree, there's not only a hollow at the base, there's a crack leading up to another hollow, and I was able to get a tape measure 15 inches into this tree, and this was a 20-inch diameter tree at this point, and there's about an inch of thickness of bark, and it leaves this tree with about somewhere around an inch of soundwood, so not a lot of soundwood for that size tree. And nesting holes, you can see on this diagram, you're going to be able to see these nesting holes up in the crown of the tree. And basically they're just like cavities, but they're occupied by critters. And so some of these animals that would utilize a tree for nesting in cavities, they can expand that column of decay and that cavity in that tree by their activity. And like it might, these could be discrete, and someone might look at this and go, that doesn't look too significant. But this particular tree actually was hollow all the way from the base up past this nesting hole and all the way up into the branches. And this was, several squirrels were living in this. And some people are hesitant to remove trees like this because of the habitat, and they don't recognize it as a hazard and a defect. But you definitely wouldn't want a tree that was this hollowed out near a house or structure or roadway. And here's a widowmaker. There's a broken branch up in the crown. It doesn't always have to be a broken branch. This could just be, it's a hung up branch or the top of a tree that's, it hasn't made it all the way to the ground. It's hung up in there, and it could come out at any point in time. These widowmakers indicate it's a previous failure. And in this particular example here, I'm circling kind of where this branch broke, and it's a little bit more obvious because the leaves are off the tree. But when the leaves are on the tree, that might not be as obvious, and that this could create a greater potential for failure of this other side because it takes away any dampening effect that the weight of this limb had when this is now broke and hanging there. The other thing that's important on something like this is if there's a widowmaker hanging over a sidewalk, a structure, places where people congregate again, it could come out at any point in time. Like also, if there's a tree worker or an arborist that's working on this and they don't notice this, and they go to, let's say they're felling this tree, that can become dislodged and fall and strike and seriously injure or kill the arborist or tree worker. And we see cases like this come up quite a bit. And the structural root plate. The structural root plate is, in this diagram, is showing an area around the base of the tree that extends out from the trunk. And the structural root plate correlates with the diameter of the tree. And so we can actually measure off where the structural root plate is on this tree. And the structural root plate's really important in the anchorage of the tree. And so I'll be investigating it, on an inspection, if there's any soil cracking, if this is starting to heave, or maybe an irrigation system was put in and roots were cut through, or a driveway or sidewalk were installed and those major structural roots were cut. That can instantly destabilize the tree and cause a whole tree failure. So I'm looking at those things. Sometimes you even I might see the fruiting bodies of mushroom that are popping up from like a root rot at this point because there was damage done. So those are some things that an arborist would be looking for with the structural root plate. And another common thing, fungal activity, ooze. On this diagram, there is showing some fruiting bodies, and I always say fruiting bodies, and people are like, "What are you talking about?" Well, the fruiting body is it's a mushroom or a conch is what more commonly be known as, and I do see ooze every now and then, and that's indicates wounding or fermenting liquids associated with a decayed wood, and that's something to note. But it's usually what I'm seeing is these fungal fruiting bodies. This particular fungal fruiting body is called Ganoderma applanatum, which is the artist conch, and that it's a sign of advanced decay. And although we see visual cues and defects on pretty much all trees, not all of them are going to keep us up at night. As an arborist, I see a lot of defects, but it all depends on the severity of the defect. And like sometimes it's combinations of those defects that could lead to a greater likelihood of tree failure. And as we get into notice, we're looking at all these things like in the inspection, we're looking at, okay, were the ANSI standards followed? were the ANSI A300 pruning standards, where they followed when a tree worker was out on site. But we got to take into consideration, how would someone have known that this was a greater likelihood of failure? Did they get a email from a neighbor? Did they get a letter from a city telling them, hey, your tree represents a hazard or is violating their ordinance? Did a contractor come out and look at and inspect their trees and tell them, hey, you should remove this tree, or you've got some broken limbs that could fall out, you should prune it? Those are the types of notice we're looking for. And when something really bad happens, these are going to be found out. Like, should someone have known? Like, was it a standing dead tree that didn't leaf out for 3 years and was obvious? But back to this forces of nature picture, I'm looking at this going, yeah, a tree failed, and this was from a hurricane. So hurricane force winds came in, but this can be really complicated if this tree, the hurricane force winds would take out a perfectly sound tree, but it complicates it if there's a number of defects that should have been known prior to that. And whether there was notice prior to that we're looking at those types of things in an investigation. And the cause, that's where it doesn't always have, we've talked about forces of nature quite a bit, but it doesn't always have to be an extreme wind that causes the tree to fall. It could be someone that improperly felled the tree. They might have made some missteps in the felling process, and the tree went completely the wrong way. Or we might be talking about someone was removing a tree and they had no training and didn't even realize what they were getting into, and the tree went the wrong way, or something went catastrophically wrong and someone got hurt. And of course, we mentioned forces of nature, but we kind of touched on the irresponsible person. And maybe they have this tree that has been standing there dead for a long time, hasn't leafed out, and they just didn't want to pay for the removal of the tree. Or there could just be some major advanced decay in the tree, but a lot of times it's more than one thing. Like then advanced decay, it might be a couple different defects. Or like we mentioned in when we're talking about the structural root plate, was there damage done to the tree? Were the roots cut through? We've seen it where roots were cut 1 foot away from the trunk of a large tree, and sometimes that will topple the tree right away. Other times the tree will stand for a little bit before it catches the right wind and tips over. But in causation, those are some of the things that we end up seeing in these tree cases. And I bring up these top 5 subtleties in tree cases because there's sometimes a misconception that, oh, well, the tree had a full set of leaves, but that doesn't always mean that it could have had like we talked about, that large cavities in those trees. It might have a full set of leaves, but it might be ready to tip over at any moment because of the amount of decay in the trunk. And when we're talking about ownership can be a little bit nuanced. It's generally goes off of the center of the tree, not measured to just the side of the tree. It's to the center of the tree. And it can also be, there can be joint ownership on these boundary line trees, or there's some cases where previous maintenance history on a tree can actually be considered ownership of the tree. And there's case precedents with that. But when some of that stuff factors into the responsibility, depending on the property ownership, depending on what entity owns the property, whether there's an easement, a lot of that falls into responsibility of who would be responsible for the tree. And the significance of decay. We talked about decay and advanced decay, but just because decay is present in the tree, and when a tree fails and it opens up the tree and there's decay, it seems like, oh, there's always that, oh, it's because of the decay that it failed. Decay doesn't always completely destabilize a tree. There can be significant amounts of decay in a tree that don't significantly weaken that tree and make it more prone to failure. And the other kind of subtlety is property lines and easements. Just because a tree fails onto one property, it's still important to measure off to that center of the tree to know, like, okay, is there a right of way or an easement in place? And I've just encountered that a number of times where that might have been overlooked early on in the case. But with that, I guess I'll open it up to any questions that came in.
Thank you, Chris. We do have a couple questions actually. First one is, how can you determine what length of time it took for a defect like a cavity to form to the point where a failure happened?
So with a cavity, a lot of times that's been present long enough. There's a significant amount of time for a cavity to form. But when we're looking at using, time frames for different defects on trees, or whether a tree screened like a stop sign for a time, we're looking at the annual growth increment on the terminal buds of the trees for like growth like that. Or we're also looking at trees lay down their wood in rings where there's summer wood and spring wood, and you can count the rings, and so you can use that to measure some, how long some of these defects have been in place. And also there's the orientation of certain mushroom fruiting bodies can play into that too.
Okay, that makes sense. Kind of on a similar note, how do you determine if a limb failure is due to nature, weather, or decay?
A lot of times with a limb failure, we would look at the actual historic weather for that area, whether there was a defect associated with that limb, which there's one that's called included bark that will make it likelier to fail, whether the wood was dead and brittle. All those, there's a number of different things that we look at for a limb failure, whether there's rot present or there's other previous damage. And sometimes even going back, like kind of relating still to that other question, we can look at these like Google Street Views that are it's amazing what I can see from some of those, like, oh, this had large deadwood in the canopy, like, and this shot was taken a month prior to that, and then that large, you can go back and go, oh, now that large deadwood is actually what was the failure. So we look at a lot of those different things there.
We just got questions pouring in, Chris.
Okay.
Another one. What does a lack of leaves on a tree outside of the fall season potentially tell you as an arborist about potential issues with the tree? So like, I guess if it's spring or summer and the tree has no leaves.
Yeah, so if a tree doesn't leaf out, it does depend somewhat on the period of time. There are times that a tree will have a late leaf out, or a weather condition will cause it will kill the buds on the tree, so it won't leaf out right away, and it might take a month or later. But if a tree has been standing there without leaves and doesn't leaf out from year to year, that tree is no longer able to collect energy to actually continue with its systems and put on new growth, and it just deteriorates from there. So that's the timing of that is huge. And a defoliating event where, let's say, the tree has leaves and it's insect killed and they drop, or oak wilt drops a bunch of leaves right away, that can be a lethal disease that you'd look at too.
Okay.
But it could be insects. Generally with insects, the leaves will cling. With diseases, they'll drop. And if they haven't leafed out in multiple years, they're going to decline and become destabilized because of rot. And
Okay. Now, next question. How difficult is it to assess causation if the tree is not available for inspection, only photos?
I'm surprised by what can be detected from the right pictures. And the right pictures will pretty much provide everything. But in some cases, it might not be enough information. It is kind of one of those, it depends, but you can tell a lot from pictures, especially being able to zoom in, taking the right shots. And I guess that's the thing too, as an arborist, I might pick up some different things from these pictures that right away. And one of them that gets brought up a lot, like you'll look at a tree failure, a picture of it, and like, why'd this happen? And like, oh, when was that bike path put in? And that's right within, it's right next to whatever, it's in the structural root plate. And that's something that a lot of people don't consider. And some people, like I mentioned, that carrot type root system. And the roots of those trees actually will go like 2 to 3 times the height of the tree in many cases. And so different things like that can be picked up from a photo.
Okay. Changing gears a little bit. Can trees live forever if they are properly cared for and have not contracted diseases, or do they have lifespans?
They do have lifespans, and there's a lot of depending on like what that lifespan is going to depend on the species of tree and the different circumstances. But there are some trees that are thousands of years old, and there are some trees that are relatively short-lived, but they have to, as long as they're able to continue to generate growth, they can live a really long time. And even some of those bonsai trees, they're small fragment of growth, allowing them to continue their processes from year to year.
All right. Well, nothing is forever, including this webinar. So that was great. I'm glad that we were able to answer so many questions from our attendees. If anyone has follow-up questions, Chris's contact info is on the screen. If you'd like to submit an inquiry, send that over to inquiries@robsonforensic.com and we can run a conflict check first. And reach out to us with any questions that you might have. Thank you so much, Chris, for this presentation. And thank you everybody for attending.
Thank you all for your attendance.